So the last part I wanted to cover was a quick review on transformers. Now, most of this is not worth going through. You know it very well, how a transformer works. But there's a couple of things that you can pick up is that isolation or transformers in general greatly reduce high frequency and voltage spikes coming through. It's an inductor. An inductor will resist a fast voltage or current change. So when you have a spike of voltage on this line, a big spike coming through the transformer on the secondary, it becomes a very small spike. So that's one characteristic that transformers have. This is just going to back through turns ratio. Nothing you need. Construction. We went all through this in PT and D1. Single line diagrams showing the configuration, delta or Y, and the voltage in primary and secondary. And harmonics. Again, it's a voltage superimposed on top of our 60 Hertz voltage signal. And you get distortion. With those harmonics, it really messes up the waveform. The harmonic is a multiple of our 60 Hertz. So it would be 120, 240, 480, and so on would be the frequency. And again, the possible causes of harmonics. VFDs, they send a lot of noise back up the feed lines, and welders, because they stop, and give a lot of big spikes out. It's constantly putting electrical noise on the back feeding up the power source. And other kinds of devices too, poor quality lighting, unbalanced loads, etc. Now, a quick summary. How do we check a transformer? Insulation tester. That's a megger. It only tests insulation. DMMs for digital multimeter. Get the winding resistance. And you can do a DC test on it. What do we look for? The insulation resistance. Dielectric absorption ratio using the polarization index. And we check the winding resistance. So when you're doing a megger test, again, this is all from Lab 1. Why do we run it for 60 seconds? Well, you get three types of current. You get the surface leakage current. Small amounts of current will leak through the insulation no matter how good it is. And this is a constant. It is a resistance. But when you're testing a transformer with a 5,000 volt megger, and you're putting a voltage from primary to secondary, it will charge up like a capacitor. And so with a capacitor, the current flow is high at first, and as the voltage between the two plates or the two portions rise, the current will slow down, and it will decay at a certain rate. So you get that charging current. And the absorption current is the polarizing current drawn by the insulation, which acts similar to a capacitor, but it's lower and decreases. So you give a 60-second test to let the capacitive charging effect drop down to 0 or almost 0. And then you get a fairly accurate reading of the actual surface leakage or the insulation leakage. How do we test? We take a megger, we go from one lead on the secondary, one lead to ground, or secondary to primary, or primary to ground. And again, standard industry test is 60 seconds. It lets the current stabilize. The rule of thumb for insulation on transformers, 1 megohm per kilovolt, plus 1 meg. Example, and this was in Lab 1, 155,000 volts would need a minimum of what to stay in service? Well, 155 kV equals 155 megs, plus 1 extra, that's 156 megs. This is only a guideline and is the absolute minimum, and it should be temperature corrected. So for every 10 degrees of increase, the resistance drops by half. Or for every 10 degrees decrease, you can double it. So correction factor to 40. At 40, the correction factor is 1. If you measure something at 10 degrees Celsius, the resistance is going to appear a lot higher. So the multiplier is 0.13, which would bring the resistance reading down at 40 degrees. So you would multiply your reading by 0.13, and that would give you the value at 40, which is standard, and see if it still passes. So that's just a last little sort of summary again, review of transformers and testing.